know you guys missed the warm-ups. What? What do you mean? Warm-ups are fun. Warm-ups aren't bad. You guys ready to go? Yeah. Will? Good? Sweet. All right. With only 3 slides, I'm going to stand up. It's going to be that quick, maybe. All right, so 6.6, inequalities in 2 triangles. So far, what we've been looking at is things like, if we, oh, that's not good. I'll draw it a little bigger. We've been looking at, like, if we have a triangle, and let's say this is 60 degrees, this is 70 degrees, what does that leave us with? 50? No. Yeah. Really?
Yeah.
Oh yeah, it does. And this is 50 degrees. We have looked at things that tell us like something about the sides, right? The side across from our smallest angle is our smallest side, which this picture doesn't show very well. And then our second smallest side, and then our largest side, right? That's what we've looked at so far kind of in the second half of the chapter. We've also looked at, kind of on the other hand, let's say 8 and 7, that the angle across from our smallest side is our smallest angle, right? That's kind of where we started. And then we move to, if we have a triangle, and they tell us that this side is 5 and this side is 7, that if we add these 2 sides together, they have to be larger than this third side. So we've kind of given parameters on what this third side could be. We today are going to just look at one other, well, technically it's 2 theorems, but it's a theorem and a converse, so kind of one. We're going to look at one other theorem that is not a trick, but maybe a little bit of a rule, kind of like these. And it's called the hinge theorem. So why don't you take a second, and write this down. I don't know if I would write all of this down yet. Maybe just write the theorem and draw the picture. And then after we talk about it, you can make a couple notes of what we talk about. But that's a pretty good amount to write down. But definitely get the picture down, get the name of the theorem, which I remember this time. Remember to put the name of the theorem up there. Picture and the name, and we'll talk about it. Will, are you getting your notes down? Let's go. Get your notes out. Kylie, you getting these notes down? All right. Remember, we can't use our iPad on the test, so we need it on paper. Kylie, we need our notes on paper.
I get it. I know what these are. I get it.
All right. I'm just making sure. Don't have to get sassy with me. We'll go like 30 more seconds to get the picture down. Name of the theorem. So, or 10 more seconds. So the hinge theorem says, I mean, it's a lot of words there, but it completely, I mean, it kind of makes sense. If we have 2 triangles that have 2 congruent sides, okay? And then the included angle. This is what we're focused on, is the included angle. When have we heard the term included angle before?
On like the first try.
On what?
First try.
First try, okay. Yep, a little bit more specific. Someone said proofs. Does anyone know what proof specifically? Which proof did we have to have the included angle?
Was it
heard alternate interior and side angle side. Kind of on the right track with alternate interior, side angle side is what I was looking for, right? We were proving that two triangles are congruent by side angle side. They had to have sides, the included angle, and then a side that were congruent. Okay? So the point of this theorem is if we have two congruent sides and then that inclusive angle on this first triangle, that 88 is bigger than 35, right? 88 is bigger than 35, right?
Yeah.
Okay, thank you. Just making sure. Since they tell us that these two sides are congruent, then the only side that's in question would be the third side. Okay? Since we've got a larger angle here, then we know that this third side is larger than the third side of ST, which kind of makes sense, right? Right?
Yes.
Okay. Perfect. Now, from what we've learned, wait, who's went to the next slide already? Don't go to the next slide yet. Go back, go back. From what we've learned about the converse of some things, what would we think the converse of the hinge theorem would be? From what we've learned about converses, or if you've cheated and went ahead, then you can tell us too. But if you haven't cheated yet, what would we think the converse would be? We have what? We have this side?
Yeah.
So you're telling me you think the converse says, so you're telling me the converse, you think the converse says that we don't know this, and they tell you maybe that this is, that's what you're saying? That means that V is larger than R? Angle V?
Yeah. Yes.
Let's see. Oh, look at that!
Whoa.
Nice job, Ethan. Did you cheat?
No.
Braden.
It's the exact opposite.
Cole? Did he cheat?
No, commerce are very easy.
All right, good job. The converse. Go ahead, take a second to write that down and draw the picture. The converse says, like I was talking about, this time they don't give us the angle. They give us that third side. Okay? And based on that third side, whichever one is longer, whichever one has the longer third side, would have the wider angle, the larger angle. That's all the new learning we have for today. They did throw a bunch of stuff with proofs into this lesson, but we're not going to pay too much attention to that. Again, I wouldn't worry about writing all this down word for word.
So you need all three sides.
So they do give you all three sides. Yep. In the converse, they give you all three sides. They tell you two of the sides are congruent. And then they give you an actual length of this third side. So what they would be looking for you to know in a question is that angle C is larger than angle F. We did. We're just giving it a theorem now.
What's the point of the other theorem?
What's the point of what other theorem?
6.12.
This one?
Yeah.
So with this one, they don't give you this side, right? They give you the angles, and you need to know that this side is larger than this side.
Oh, because of the angle.
Right, because of the angle. Here they give you the sides, and you need to know that this angle is larger than that angle. Yep. Now we just have one example. Give like 15 more seconds to get this done. here's our example. Given that JK is congruent to LK, how does JM compare to LM? So the way that we would set this up, JM, LM, and then we need to say if it's greater than or less than. Yeah. It's greater than. JM is greater than LM. Why?
Because the angle is larger.
Right, because 64 is larger than 61. So this side is larger than that one. Cool. That's our application. Now they will throw some like real life situations. I think there's some stuff with like an airplane and an airport and some other stuff like that. But nothing too crazy. Do we have any questions? Any questions? Okay. There is, it's 1 page, 2 questions on class K. And you need to, well, it'll say it in the question. Never mind.